Okay, so this is me getting some of the data put together for what we're going to use for one of our first lab reports. Now, I'm doing this in kind of a different set of programs, so bear with me. I'm a little off on this. I usually use a different program at home. Unfortunately, I have an exceedingly old version of Excel at home, so old that it won't look familiar. So in short, I'm going to try this using a slightly different setup than I'm used to. Now for that, I've got it set up on a different computer, and here we are. Now I'm going to walk you through exactly what I want you to get put together for the first lab report. Now I'm not going to do the entire lab report. Take a look at the video and the other documents that I have available for you, because there's going to be a lot of typing stuff where you explain what's going on. But I'm going to show you some of the data side of this. Now I've saved us a little bit of time by already typing in my data. So I've got an Excel spreadsheet here with all of my data. I have my material. As a reminder, we measured ball bearings of various materials. We measured their diameter using calipers, and we measured their mass using scales. Now, a few of the masses I filled in for you because I have some more advanced scales that can measure very lightweight things. But if you check back to the sample data, which is uploaded into our class website, take a look on the page that actually has things for section 0. You'll find that I've supplied you with that. So if you're missing some data, check Canvas. There's actually a page and you're looking for lab 000C sample data. I've updated it with all the information that I have here, so you'll see that this is the same data as that. So I've got 5 data points for nylon from diameters ranging from 0.3 centimeters all the way up to 2.5 centimeters. I have masses that I weighed with a high-powered scale, and then we had a few that you all filled in. Now, same thing with steel, brass, and wood. Now we're going to start working with those. So first step is to actually get those put into Excel so that we can do math with them. Now you can manually do this, but I will say this. I'm also going to do the following. If I highlight over these, I can also come up here to center text. I can center it. And then I can also come to here where I've got like a little grid with outlines on it. If you do this, this is borders. You can do all borders. And now, in fact, let me open this up real quick. I'll show you. Let's say that you have gotten to your section of the lab report, data. Now this one's kind of small. Let me make this a little bit bigger. I'm zoomed way out. There we go. That's a little bit better. One of the things I ask you for is your raw data. Well, this is your raw data. So you can highlight over it, Control C or right click and copy, and then take it over to Excel and bam, right in there. Now all of your data is put in there. So there's an upside to actually typing it in Excel. We can get it in a nice, neat little grid, complete with the border and everything centered. Everything looks great. Now, I will point out a few things. I've got the material here, 5 nylon, 5 steel, 5 brass, and 5 wood. I've got the diameter marked with its units in centimeters, and I've got the mass marked with its units in grams. Now I'm going to do some calculations with this raw data. Now, as a reminder, in the lab report, there is a section marked data that I want you to actually show me your raw data with no math on it. Then you'll do things like data and analysis, that sort of thing, where you'll start explaining, okay, here's how we're going to get the diameter into a volume, for instance. So I'm going to do capital V for volume. That is in grams divided by centimeters cubed, just so I have some units there. Now, if you'll notice, this one's kind of crammed in there. We can come up here where it's a line that has 2 arrows, left click, and you can drag that out a little bit. You can also double click on it and it will auto space it. So if I have something really long, it will actually do that for me. All right, next thing that we want is mass in grams. Great. All right, now that I've got that, it looks like it's automatically filling in some of the formatting because it centered it and then also put brackets around it, but that's okay. We'll deal with that later. I want it to get the volume, so I'm going to teach it the volume equation. So equals, I do that whenever I want Excel to do math. The volume of a sphere, because our ball bearings are spheres, is 4/3. I'm going to put that in parentheses so that I know that it's treating it as 4/3. Times, and I'll remind you, times is the little asterisk or star. It's directly above the 9 on the number pad, or it's the secondary thing on 8 on the main keypad. I don't actually use the main keypad, I use the number pad, but that's just me. We want pi. Excel knows pi, so type in pi open parentheses, close parentheses, it will actually put the full value for pi in there, or at least to as many significant digits as it handles. So that's going to be a great way to do it. Then hit the times thing again. And now here's where we want, so the volume of a sphere is 4/3 pi r cubed. We've got the diameter though, not the radius. So I'm going to do open parentheses, click on the diameter, left click on the diameter, and I'm going to do divided by, that's the little slash above the 8 on the number pad, divided by 2, close parentheses, and I need that cubed, that whole thing, because the diameter divided by 2, which is in the parentheses, is my radius. I want that cubed. So I'm going to raise that to the third. So I hold down Shift and hit the number 6 on the main keypad. That's going to give me the up caret. That means raise this value to the following number, 3 for the third. I hit enter, and here we go. Now we have our volume based off of 4/3 pi r cubed. And since the only thing that it's calling, I can click up here, the only thing that it's actually calling is this square, I can now just drag this down. Remember the black square in the bottom right, I get a black crosshair, not a white one, but a black one. I left click, hold that down, and then I drag this down. It does all of the math for me. Now this is a bit of a mess. I'm going to clean this up a little bit. I can select the entire column of E by clicking up here, and I can right click and go to Format Cells. There we go, takes a moment. Number, it comes up as general. Let's go with number, and normally I'd do 2 decimal places, but let's go ahead and do 3 because my first few data points are actually kind of tiny, so we'll go ahead and leave the 3 data points in there. You could go through and on these bigger ones, you could select just these, and you could have it go to only 2, but I think this will be fine for now. My mass, I could type all of these in again, or I could simply have Excel say, okay, well, the mass is equal to whatever is in this square. And I hit enter, and then I just drag that down. You don't actually have to make the column again, but I like having them where I can actually work with them over here. Now, here's the big thing that we're actually going to want. I want a graph, and I want a very specific graph. I want a mass versus volume graph. Now, it's going to take us a few minutes to actually build this, but what we're going to do is we're going to put all 4 of our data sets, nylon, steel, brass, and wood, on there. So I'm going to come up here to Insert, Scatter Graph, and I'm going to do the one with just the little dots like this. Very first one there. Pardon me. Now it brings up a graph that's completely empty. Maybe if you start off clicked on some numbers, it'll bring up some stuff, but it almost guaranteed does not actually have what you want. So I'd recommend starting an empty graph. You can do that by clicking in empty space before doing Insert and Graph. Here's what we're going to do. I'm going to right click in the graph, and I'm going to go down to Select Data. Now I'm going to add some data sets. I do that by clicking here. And series name, I'm going to start off with this series will be named nylon. I'm going to add my nylon data points. My series value for the x's, now remember, I want a mass versus volume graph. So that means my x values, the horizontal, needs to be the second one, which is the volume. So here's what I'm going to do. I'm going to select all the volumes for nylon. Okay, so I've got those. And then I go to the Y values. I click this little window shade button that lets me move around in the spreadsheet. Now I want the masses for nylon. Great. You can see it's already started to fill those in. All right, that's a little weird. It was completely linear just a moment ago, but that's okay. I'm going to leave that for the time being. Click OK. Everything's looking good. And then here's what I'm going to do. I'm going to add another data set. This time I'm going to call it steel. All right, I'm going to add the X values for the volume on steel. It turns out that it's going to be very similar to the values for nylon and brass. It's the wood ones that get noticeably different. But that being said, just in case they are different, I'm going to add the ones specifically for steel. Here I am adding the masses for steel. Now you'll notice that I've got my data points mostly in a line. This one's a little tall. That's okay. Ooh, I am approaching the recording limit. That's good to know on this. Like I said, it's a new piece of software. So now that we've added that, I'm going to stop this for just a moment and we'll pick back up. And we're back. Sorry about the small jump there. Apparently this software will only let me record 10 minutes. So that's a good thing to actually keep track of. Anyway, here we are. I've got my nylon and I've got my steel. So let's keep going. We're going to add brass. Okay, my X values, let's see. I want volume for X. Remember, it's a mass versus volume graph. And my Y values, oops, there we go. There we go, starting with brass, ending with brass. Great. Now I've got those as little green triangles. Okay, cool. I'm going to do add, the last one, wood. Now this one's going to have probably noticeably different stuff because it has a different volume range. We had much larger wooden spheres. And you'll notice the moment I add it, my graph seems to get pretty crazy because I've got multiple ones actually graphed on here. That's okay. I'm going to have you go ahead and graph it this way because that's more or less what I want. Now that we've got all of them, great. I'm going to click OK. And now we're going to go in, we're going to do some chart options. So let's see, chart tools up here in the newer versions of Excel. We can go to format, layout, chart title. None. Let's go above chart. We're going to do chart title and we're going to do mass versus volume. Great. Layout. Other things that we want, axes, horizontal axis. Let's show, let's see, default axis. No, that's not what I wanted. Yes, okay. Sorry about that. Axes, horizontal axis. I need labels. Sorry, axis titles. It's been a while since I used this version. Like I said, I'm used to the older one where it's actually a lot worse. Axis title, we're going to call this volume. And it's going to be in centimeters cubed. Great. Axis titles, we're going to go with the vertical axis. You can do a rotated, you can do all sorts of stuff. Let's do a rotated one. We're going to do mass in grams. Great. Now we've actually marked our graph. And we've got a legend over here, the little blue dots, that's my nylon. The red squares is my steel. The green triangles are my brass. And then the purple X's, it looks like, are wood. Now down here on the bottom, I can actually zoom in a little bit so I can see this a little bit clearer. You can also drag this here and expand it a little bit in case you need to be able to see it a little bit better. Here's where we're going to go in and add our trend lines. I want you to left click on one of the data sets. I'm going to start on wood. Right click and go to add trend line. This is probably a linear one. In fact, if you look at it, yeah, that looks pretty linear. We could try some of the others, but we're actually expecting a linear relationship here. It's one of the things that we worked with. We found the volume. We expect there to be a linear relationship with the mass. And specifically, if you have a mass versus volume graph, the slope of our line should be, because we'd be in grams per cubic centimeter, it should be our density. All right. Last thing to remember, because we're going to do this a lot, display equation on chart. That's a really important one to have. I'm going to click close. Here's our equation. I'm going to drag this down a little bit. Wood is the very last one, so I'm going to put it on the very bottom so I can keep track of it. But we said that y, our vertical value, that's actually our mass, equals our slope, mx plus b. Let's ignore the plus b for now. We have m is our y, our mass, and then x is our volume. The slope of this should be our density. Now, I mentioned that the density of this wood, oh, I was pasting stuff there. We'll get back to that. But you can double check the lab handout that I gave you. The density of the wood, I think, is about 0.67 centimeter or grams per cubic centimeter. We're a little high on that. Let's see some of the others. Here's nylon. I left click on the blue ones. Add trend line, they're little diamonds, they're linear. Don't forget the display equation on chart. That's how we get Excel to do the math for us. That's odd. Okay, so the slope that it's giving me here is 1.0. I do not think that that's what the slope was supposed to be. Let's see, is this my right data? I believe it is. I thought I ended up with something different because I ran through this before. Nope, that looks fine. I'm just crazy. Ignore me. All right. So we've got this. That is nylon. I apologize about that. Now I'm going to do steel. Left click on it. Right click. We're going to add trend line. Oh, I accidentally right clicked on the brass. I'll show you that in just a moment. I'm going to display equation on chart. But as I right clicked, I saw that my little lines were around the triangles. So here's what I'm going to do. I'm going to drag brass over here. And you'll notice over here, see it says linear for brass, but it doesn't have one for steel yet. Now I'm going to click on steel and right click for steel. Here we go. Now I've got one for steel, display equation on chart. The only difficult part on this is making certain that you get the right ones in the right spot. So here we go. Here's nylon. Let's see, my slope is coming up to a little over 1. Here's steel, I've got about 7.9. Here's brass, about 8.5. Oh, and if you hover over it, see it says series brass trend line 1. Here is series wood trend line 1. So if you're having trouble with that, hover over them. But we just want to get those kind of put in place. We'll see if we can get those marked. The problem is, especially with the steel and the brass, they're so close together that I'm reluctant to have you try and cram these by the ones that they are. So if nothing else, if you put them in the same order as the actual legend stuff, then we can go through and we can work with that. This is where you'll also collect your results from this. We would say that our density for the nylon that we measured, at least with the data I have here, your data may be different. We've got about 1.0. And then for steel, we've got about 7.9. For brass, we've got about 8.5, and for wood, we've got about 0.72. Now, the actual values, if I'm not mistaken, nylon is actually about 1.15. Steel, at least the steel that we're using, should be about 8.05. So we're a little bit off on that. We're noticeably off on the nylon. And let's see, brass, 8.5 is pretty much exactly where brass is supposed to be. And for the wood, we're a little bit off. I think it's supposed to be 0.67. Double check the results that we have in there. That's okay. In fact, one of the things that I want you to explain in your lab report is why your numbers might be a little bit off. We don't expect it to be perfect. Now, one of the other things to note on this is, and this is where the best fit trend lines come in. We've got some data points that are a little above, and we've got some data points that are a little below. And then you'll find that that's the same with all of these. This is why we do multiple measurements. Now, what are some things that may be throwing off how we actually did this? Well, take a look back at what we actually did in class, some of the equipment, because I mentioned to you that some of our equipment was probably not the best stuff to use for something as light as this. In fact, I'll remind you at the beginning of this, I told you for the exceedingly lightweight ones, I use special equipment because what you all would have wouldn't be able to measure it. In particular, these two data points, you'll notice that they don't have any fractions of a gram. The scales that I gave you weren't set to actually measure that. So that's something to think about. There are a lot of other things that might be throwing off the data as well. All right, let's finish up the actual important stuff for other things that will help you with the lab report. Let's go ahead and center these so they look nice. I'm going to put a grid around them, and then I could go in here and I can copy this as part of my analysis and calculations. Calculations, wherever you'd put those in, you would explain, we found the volume by 4/3 pi r cubed. Go ahead and make it a little bit prettier than this. We could do 4/3 times pi times r cubed. Also with pi, we could replace that with insert symbol. And then look, it's right there, pi r cubed. We could also do subscripts and superscripts, that sort of thing, but I leave that to you. We found the volume by doing that with the diameter. Another way of writing that, oops, I put VV. Anyway, another way of writing that would be we divided the diameter by 2, we cubed that, then we multiplied it by pi and multiplied it by 4/3. Explain where you're getting the data from. Then after you have that, you can paste your data table in. Now, one thing that's kind of bad about this, the way that I've got it set up, it's kind of cut off. We actually call that truncating. So if you need, you can also do the following. You can always select a page break here. That way it's all on one page. Especially with your data or calculations, it helps if all of your table is on one page. Now, for the most part, we may not even be printing these off, so you don't have to worry about that full extent there. And then finally, I'm nearing the end of this recording, we obtained the following graph. Select the graph, copy it, and then you can paste it right in. Now you'll notice the graph won't allow itself to be truncated, so it actually got cut there. Okay, so probably the last part of the video, because the rest of this stuff is things that you all can work with. Take a look at the sample documents to actually fill in the stuff. I do not want something where it says calculations and you've just dropped this in here. Explain to me what calculations you're doing and how you got them. Graphs, you can tell me more or less what the graph is. A lot of times the graph can stand by itself because it'll have mass versus volume. It'll have the correct units. We could have done something on this to make the units less, like 30.000. You can actually play around with. It's pulling the volume, and I said to take that to 3 significant figures. So we could actually go in. In fact, let's take a quick peek at that. I think we can right-click on this, format axis, and we could go in and use, let's see, axis options, number. Here is where on the graph we could actually fix this up. Let's do it to 1 decimal place. Close. There we go. That looks a lot better. So let's copy this, and we will delete this one and paste this one in. So you'll notice that that looks a lot better. Anything you can do to try and make things look a little bit better would probably be nice. Now in here, when you talk about the conclusions of your graph, notice I haven't marked this one specifically, and I can hover over it, but when people are actually reading this in text form, if and when that happens, they can't actually do that. You want to have in your actual descriptions, we found nylon's density to be 1.00 grams per cubic centimeter. You might talk a little bit about significant figures in that. Do we know it to 3 significant figures? Here's the one place that it might be best to be thinking about significant figures. Take a look at your actual data. Do we think we know it to 3 significant figures? Probably not. In fact, think long and hard about how many zeros or whatever else we could put on here, and that also describes how accurate we think we're going to be able to get this, and how precise. All right, we found nylon's density to be this, while we found steel to be this, and brass to be this, and wood to be this, and then talk about your conclusions. Well, nylon might actually be a pretty good value, or it might not. It depends on what your conclusions are. Think about how well our measurement will actually represent this. Remember, computers don't think. It's given me 5 or 6 significant figures. We're not actually doing that. Do we think that we know this that well to quote it to that many numbers? Think about what those numbers mean. That's a big part of what physics is. If you look in here, we might only know these things to arguably 1 significant digit, maybe 2. Do your best to kind of think and argue about what you think it might be. All right, but here's where we get our conclusions from. You also have other conclusions that you had from doing the averaging. You're welcome to talk about those as well. Include that. You could actually put that in as a result in here with the calculations. Do an average. That being said, here's the main thing that I actually want. We definitely want a graph. We want the best fit lines. I want several of the things graphed on that, so several different materials, so we can compare them. And I definitely want the equations for the lines for those best fit lines. Now, this is only part of the lab report, but this should get you started and deal with most of the Excel stuff. Feel free to ask me any questions or anything like that if you have any other concerns. But this walks you through the important things from taking our raw data to calculating up the volume and generating our mass versus volume graph, cleaning it up some with axes labels and units, and finding our best fit lines with our slopes that can tell us the actual density. All right, we'll go ahead and stop there.